Okay, here we go. We've got assignment 8, lesson 8, distance learning for Algebra 1. It's our second week with the quadratic formula. So I've written the quadratic formula up here. You should remember it from your work that you did last week. But solutions to any equation of the form ax squared plus bx plus c, where a, b, and c are just numbers. As long as a is not 0. A is 0, it's no longer quadratic. But a, b, and c are just numbers. You get the solutions by saying x equals negative b, or opposite sign of whatever this is. That's negative, then this is positive. Plus or minus square root. Inside the square root is b squared minus 4 times a times c. All of that's divided by 2 times a. Okay. So our goals today, we're going to do more just regular quadratic formula equations where the answers aren't quite so nice. Previous ones, they were fractions or whole numbers. In this case, or fractions or integers. In this case, we're going to have some irrational numbers. So square roots, like a square root of 5, which is not rational. You can't square root 5 and get like a nice number with a decimal expansion that stops. Doesn't work that way. And see like what happens. Hey, maybe there's no solutions. So we're going to look at that. We're going to investigate that. We're going to talk about how the quadratic formula, what kind of info that gives us about the graph. And then we're going to do a contextual problem as well. So let's go ahead and get started. I'm going to do problems 1 and 2 from the assignment here. So problem 1 is just saying use the quadratic formula to solve the equation. So just like we did last week. Here we've got negative x squared plus 4x plus 17 equals 10. Okay, so just like last week, step 1 is going to be taking this, make it equal 0. Quadratic formula only works when it's equal to 0. So we got to subtract 10 from each side. So we go minus 10 minus 10. Awesome. So here, negative x squared plus 4x plus 7 equals 0. Okay, cool. So we've got it equal to 0. Now we're going to identify what's a, what's b, what's c from. So we put it in the quadratic formula. So here it's a negative x squared. So we're going to say a equals negative 1. It's 4x, so b equals 4. And then it's got a plus 7, so c equals 7. So now we're going to take negative 1, 4, and 7 and put them into that quadratic formula. So let's say x equals, my solutions are going to be opposite of b, so negative 4, plus or minus the square root of 4 squared. I'm just going to square it. What's 4 squared? 16. Minus 4 times a, which is negative 1. Remember, we put that in parentheses. And then times c, which is 7. And then it's all divided by 2 times a, which is 2 times negative 1 in this case. Now we're going to go about simplifying it and find our answers. So here I'm going to take this square root. This is the square root of 16 plus 28, right? Because 4 times 7 is 28. And I've got 2 negatives. I have a minus and a negative, so that makes it a plus, right? And then here I'm going to add the 16 and the 28, right? And that's going to give me 44. So here this is square root of 44. Because 16 plus 28 is 44. So I'm just going to rewrite it. I just did that little bit of work without writing everything else out again. So x equals negative 4 plus or minus the square root of 44, all divided by negative 2. Like, oh, what's the square root of 44? Well, we know the square root of 49 is 7, and the square root of 36 is 6, so it's some number between 6 and 7. Well, it's not actually like a nice number that we can just write out. So what we're going to do is we're just going to simplify this square root of 44. Like, hey, square root of 44, 44 is what times what? It's 4 times 11. So this is the square root of 4 times the square root of 11. And what's the square root of 4? It's 2. So it's 2 square roots of 11. Right, remember we did this in like section 9.2 when we're solving by working backwards, solving by square roots. So here I can rewrite this square root of 44 as 2 times the square root of 11. So here x equals negative 4 plus or minus 2 square roots of 11 over 2. And we can do a little algebra trick here. I want to simplify this. So what I can do is I can split this fraction apart. Everything's getting divided by 2, right? That's being divided by 2, that's being divided by 2. So I can kind of like distribute the division to each part of this adding, subtracting to get -4 over 2 plus or minus 2 square roots of 11 over 2. And now I can simplify each piece. I've got 4 divided by 2, which is -2, plus or minus, see how there's a 2 in the numerator and a 2 in the denominator, right? But not the square root, we don't worry about the square root. It's 2 divided by 2, which is just 1, so here it's just square root of 11. So for my final answer, I'm going to say -2 plus square root of 11, or -2 minus the square root of 11. And I want the answers like that. So you have that square root of 11 still in your answer. If you get here and you're like, I don't know how to do it, that's okay. You could leave this like +1 is a plus, 1 is a minus. I'll still give you most of the points for that because you're showing that you can do it. But I want to see the simplifying. Give it a shot. Try simplifying. Okay, so that's problem 1. Let's do problem 2. Let's change up the colors. Okay, so problem 2. Problem 2, we have 2x squared plus 8x plus 10. 2x squared plus 8x plus 10 equals 1. Sorry, equals -1. There we go. Gotta double check that I wrote everything correctly. It's good. Here we're going to look at it and go, all right. In order to use the quadratic formula, it needs to equal 0. It's equal to -1. We're going to do the opposite of -1, which is +1, +1, +1. And that gives me 2x squared plus 8x plus 11 equals 0. Awesome, now it's equal to 0, so we can use the quadratic formula. Identify what's A, what's B, what's C, right? A, B, C, so A equals 2, B equals 8, C is 11, and we're going to plop it in there for that quadratic formula. So we're going to say x equals -b, so -8 plus or minus the square root of 8 squared. We're just going to square that. We can do that. 8 times 8 is 64. Minus 4 times a, which is 2, times c, which is 11. And then divided by 2 times a, so 2 times 2. And remember how in the last problem, I kind of looked at this thing under the square root? This thing under the square root, this b squared minus 4ac, we call that the discriminant. We're going to see why we call it the discriminant right now. So I'm going to look at this 64 minus 4 times 2 times 11. I'm going to say, well, what's 4 times 2 times 11? Right, just like I did here. Say, well, 4, 2, and 11 are all positive, so I'm just going to keep it as a minus sign, so I'm subtracting the product of 3 positive things. So this is going to give me 64 minus 4 times 2 is 8, 8 times 11 is 88. So here we have the square root of 64 minus 88, right? So that's what? We got to go 4 and then 10, so it's what, 14 away? 24 away, sorry. Extra 1 in there. So this is the square root of what kind of 24? I have small minus big, so it's a negative 24. Now what happens when we square root a negative? Right? There are no real solutions. We get what are called imaginary numbers, which make up the complex number system, which you'll learn about in Algebra 2 and pre-calculus. But in Algebra 1, we look at that and we're like, hey, it's a square root of a negative. Can't do that in the real number system. So we just jump straight to the answer, which is no real solutions. Boom, and that's it. There's no real solutions. So we look at what's under the square root. If that turns out to be negative, then we just say no real solutions. If it turns out to be positive, then we got to simplify if it doesn't come out to like a perfect square root. Okay, so once again, look at the discriminant, this b squared minus 4ac. If it turns out that that is negative, like this negative 24, then you can just jump straight, no real solutions. If this discriminant under the square root is positive, you will get 2 solutions. And you got to write those solutions out, plus one thing minus the other thing. Right? If you get a 0 here, guess how many solutions? 0. Cool. All right, so that's problems 1 and 2. Try problems 3, 4, and 5, and 6. And so pause the video, try those 4, and I'm going to do problem 7 for you. So while I'm erasing, right, you got plenty of time to pause the video. Here we go. Try to leave this pink writing up here, though. There we go. Yeah. It's good to kind of have that quadratic formula written somewhere. It's actually written on your assignment for you. I put it up there as like the learning target idea, but it's good to write it out. It's good to know it. You can Google some people singing songs about it. I'm not going to make you listen to that. I'm sure you would just fast forward anyway. You don't want to hear me sing. Okay. Here we go. Problem 7. Let's go pink for problem 7. So problem 7 here, what we're doing is we've got this equation, y equals 3x squared plus 5x plus 2. And what we're being asked to do here, it's y equals. There's no way to make that 0 equals, really. We can't just like subtract y because I'm going to have y. So what we're doing, we're being asked to find the x-intercepts of this quadratic function, of this equation. If we were to graph it, where would it cross the x-axis? So what we do is say, hey, the x-axis, right? Here is x, here is y, right? Above the x-axis, y is positive. Below the x-axis, y is negative. On the x-axis, where the x-intercepts are, right? This is where y equals 0. Right? The x-axis is when y equals 0. So what we do, if we're saying find the x-intercepts, find x-intercepts, that means basically just solve when it equals 0. So what we're going to do is we're going to rewrite it, and the only difference here is we're going to rewrite it as equals 0, and then we're going to write our answers as x-intercepts. So here I'm going to say 0 equals 3x squared plus 5x plus 2. And I'm going to identify a, b, and c. Here, a equals 3, b equals 5, c equals 2. Now I'm going to use my quadratic formula. So x equals negative b, so negative 5, plus or minus the square root, b squared, 5 times 5 is 25, minus 4 times a times c, divided by 2 times a. Okay, so I got my quadratic formula. I'm going to look at that discriminant and simplify that to kind of see what's going on there. Hey, maybe if that's negative, we have a negative in that square root, then there's no real solutions, which means no x-intercepts. Like it could be a parabola up here. Or if this was negative, it could be a parabola down here, opening down but below the x-axis. Here it would have to be parabola up here, positive above the x-axis. Not the case though here, because if I look at 4 times 3, that's 12. 12 times 2, 12 times 2 is 24. So we get 25 minus 24 inside that square root, which is just 1. And the square root of 1 is just 1. So the discriminant, that that b squared minus 4ac, that part is 25 minus 24, which is 1. Square root of that 1, we get 1. We can just jump straight to saying, hey, this whole thing, that square root, is the square root of 1, which is just 1. So I can say x equals negative 5 plus or minus 1 over 6. And I'm just going to break it into 2 pieces. And it's nice, right? Square root of 1 is 1. We don't have any of this crazy square root stuff. So going here, I'm going to say negative 5 plus 1 over 6, which is negative 4 over 6, which simplifies to negative 2/3. Okay. And then I have negative 5 minus 6, minus 1, so 1 over 6. The 6 is in the denominator. All right, that is going to give me negative 6 over 6, which is negative 1. So we've got 2 answers here. But we're not just finding what x is, we're finding the x-intercepts. So I need to write these as x-intercepts. So I'm going to say x-intercepts for my answers are the points on the graph. -1, 0. So that'd be like there. And then -2/3, 0. So that'd be like there. So basically our graph would look something like that. It'd be real steep, squished together. The vertex would be just like right below in between those 2 points. Cool. So in this case, if you think about it, if I were to sketch a graph, I could have a graph that hits twice like that. It could hit twice like this, right? 2 x-intercepts. We could have a graph that has a vertex above the x-axis opening up. That's never going to cross the x-axis. It'll have no x-intercepts. So it's possible to have no x-intercepts. Also possible to have a graph like this, where the vertex is on the x-axis, and then you'll get one solution when you work through that. The case that you get one solution is when you're adding or subtracting a number that doesn't change when you add or subtract. Like, what number could I add something else without changing that number? Like 5 plus what equals 5? 0, right? So basically, if here instead of 25 minus 24, if we had 25 minus 25, and we were square rooting, or 0, right? Square root of 0 is 0. We get something plus or minus 0, which is just that thing divided by whatever. It's just one answer. Okay, so I got one more problem to work through, and then that'll be it for the video. So go ahead and try problems 8, 9, and 10 now, while I set up problem 11. Problem 11 is a 3-parter, and you're going to do problem 12, which is similar to it. So make sure you take good notes on problem 11. Okay. Boop. So problem 11 is a contextual problem. Hopefully you can catch this on the video. I'm going to try this. Where's my... Yeah, blue is probably the worst color as far as like stuff goes. So if I toss this, ready? The path that it travels is a parabola. And one of the reasons that we study parabolas, one of the many reasons, is because gravity acts on things in a quadratic manner. If you throw something like this, like up, it'll go up, and then gravity will bring it back down. And what happens, I don't know if you've ever been, I don't know, like, not a good example, but if you drop something, right, when you drop it, it starts out going kind of slow, and then it speeds up, speeds up, speeds up, speeds up. It accelerates. Gravity, the force of gravity applies, or it manifests itself basically as acceleration on an object. So the acceleration due to gravity is negative 9.8 meters per second squared, or negative 32 feet per second squared, approximately. And here we're going to use feet, just because 32 is an easier number than 9.8. So I'm going to go ahead and give you the example of the problem. So here we've got a ball launched. So there's a ball launched from a catapult, and it's got an initial upward velocity of 100 feet per second. That's the ft over s is feet per second. So it's got a speed as it gets launched out of this catapult, right? We got like this catapult, whatever. And here's the ball, right? It goes, phew. The upward velocity is 100 feet per second, and the horizontal velocity is 80 feet per second. Right? In Algebra 2 and in pre-calculus, you can find out what the total speed of it is. What we did is we took this speed and we broke it into components, a horizontal and a vertical part. Together they make the actual speed of the object, of the ball. And then here we've got a height, initial height of 10 feet. That's kind of the important information that we're given. And we've got this equation. h of t, which means the height, t seconds after it's launched, is equal to negative 16t squared, because half of the acceleration due to gravity, and because gravity pulls it down, we're making that negative. And then it's plus v sub 0 t plus h sub 0, which we call the little sub 0, we call it v naught and h naught. V naught is the initial velocity, the starting velocity, and h naught is the initial height of 10. So here we've got the equation, or the function, h of t equals negative 16t squared plus 100t plus 10. Okay. Now we're going to go about answering some questions about this function, about this equation. So first one is asking, when is the ball 110 feet from the ground? So when is it 110 feet above ground? Well, we look at the equation, it's saying 110 feet above the ground. That's going to be the height above the ground. The height is our h here in this final equation that we have. So we're going to say, at what h, when h is 110, what's that t? What's that time that gives us that? So we're going to replace the h of t with 110. So we go 110 equals negative 16t squared plus 100t plus 10. And then here, hey look, we just have a quadratic equation. We're going to make it equal 0, use the quadratic formula. So minus 110. That gives us 0 equals negative 16t squared plus 100t minus, so it's 10 minus 110, so it's minus 100. We're going to say here, what's a, b, and c? A equals negative 16, b equals 100, c equals negative 100. And we're going to just use our quadratic formula. X equals negative b, negative 100, plus or minus the square root of 100 squared minus 4 times negative 16 times negative 100, all divided by 2 times negative 16. And what do I want to do because these numbers get kind of big? Right, just grab a calculator and say, hey, what's the discriminant? Well, 100 squared minus 4 times negative 16 times negative 100. Just plop that in the calculator, hit enter, and we get 3,600. So here, this is the square root of 3,600. Just square root that real quick. Should get 60. Yep. And then we can go on, moving on. So here I have negative 100 plus or minus 60 over negative 32. Okay. So we're going to find out what are our two answers here. Well, I have negative 100 plus 60, that's negative 40 over negative 32, or negative 100 minus 60 is negative 160 over 32. We can simplify these, or we can just approximate. Or use a decimal approximation, because it's a word problem. We say this many seconds approximately. So 40 divided by 32, 1.25. Let's use a decimal there. So here this is 1.25. And then this, 160 divided by negative 32, sorry, there should be a negative there, is 5. And just double check that. Yep, that's 5. So here, we're just going to write out our word answer, which is the ball is 110 feet in the air, 1.25 seconds after being launched, and 5 seconds after being launched. So basically it gets launched, it goes up, it goes, like we draw this little graph here, starts out at 10, it goes up, woo, and then it comes back down, and it hits 110 twice, right? And that's that. So I'm gonna leave it at that, and I'm just gonna make you do one part of this, judging by kind of how long this video is going and the complexity of this, having to write out the word answer. Let's just leave it there. So I'm gonna go back, edit the assignment, so just have one problem, problem 12, just one part, similar to this. So that's it. Going back, just going through it one more time. All right, we got a ball being launched, we have a vertical and a horizontal velocity, and then we've got initial height. We look at this equation, replace the v naught, the v sub 0, with the upward velocity. We replace the h sub 0 with the initial height to get our new equation. We want to know when that ball is at a certain height. So we replace the h of t with that number and then solve. We solve, we get two answers. You might get no answers. You might get one answer, right? The vertex, and then write out a word answer from that. Okay, so that's it, and good luck with the assignment.